Now what I'm going to do in this video is talk about all those components I did in 2D and 3D now, like points, vectors, and all of those components. So let's get started. So the first thing I'm going to do is graph the point P, which is -1, 3, 1. So that means I'm going to start at the x equals -1 and go in the y direction to 3. So that is going to go this way. I'm just creating that box again that we did two-dimensionally. So there it is. And then I'm going to go in the z direction, 1. And there's my point. And I'm going to call that my point P. Okay, now I'm going to do the same thing with Q. Now I'm going to start with the 3 and the Q there. And I'm going to start graphing that one now. And I'm going to go this to the left because my y is -2 now. So then I'm going to go up with the -2 in my y, and I'm going to meet my 3 for my x. That gives me a box. Now I'm going to go to the 4 on the z-axis and just kind of work it forward. And the reason why is so I can get a nice height for my point, a better one, a more accurate one. So then I'm just going to drop this down to the x-axis, and then I'm just going to go over on the other side and just create a box here. Not a complete box, but a box to help me get a better visual of where that point's going to be in 3 space. And there it is. And I'm just going to label that point Q. Now what part C is telling me to do, it's telling me to graph the vector PQ. So this means I'm starting at P and I'm ending at Q. And I'm going to call that vector V. So I'm just going to draw a line there and then put the head towards Q because that's where I'm ending at and I'm going in that direction. Now remember, this is a line segment and it's in 3 space, but it's still a line segment. So the initial point is P and the terminal point is Q. So now if you look below here, what I'm going to do with these vectors is this first part, and where it says find down here, it says the standard position vector in component form. Now I didn't formalize these previously, but we are now. So component form is where I have my bracket, and then I have an X, a Y, and a Z. And when I get those components, that's what I'm talking about when I'm talking about component form. Standard unit form we'll talk about in a minute. Now this might be hard to see, but this vector PQ is actually going in an upward direction towards out of the screen here. And what I mean by that is if I create a square here at the base, we can kind of see that it's going in an upward because back here is 1 and up here is 4. So that just kind of tells you that it is going in an upward direction, even though it's very difficult to see with these 3-dimensional drawings two-dimensionally. Now remember, point P is -1, 3, 1, and point Q is 3, -2, 4. So essentially what I'm going to do here is I'm just going to take this point, move it down, and then move it to the left here, 3, and then move it in the positive x direction, 1. So in essence, what I'm doing is I'm going to be subtracting the initial point from the terminal point. Because remember, I want to get this initial point at the origin, and that's how I'll do that. Essentially, the mechanics of that is just actually subtracting the initial point off, just like we did in the previous section. Nothing changes here. That's what's kind of nice about it. So that means I'll take the point Q there, because that's my terminal point, and then minus my point P from that. And that will equal... but before I do that, I just kind of want to point this out to you, so keep this in mind here. So I have this 3 minus this -1, so that's really adding 1 there. So that's actually going to be 4. And then for my middle term, I have a -2 minus a +3. So that's going to be a -5. And then for my last value here, that's going to be 4 minus 1, which is 3. So there's going to be our component form of the standard position vector. So now in standard unit form, I've dealt with that already, but I haven't formalized it for you. So for that form, essentially what we're going to have is just this. This 4 here is in my I direction. So this here is really my I, my J, and my K in essence, but I don't just take them just this way, but just something to keep in mind. You'll see what that looks like right now. So this is really going to be 4I, and then since I have a minus here, or a negative, I'm going to just, excuse me, a negative, I'm going to call it a minus 5J, and then plus 3K. So that's what this is going to look like in the standard unit form. And they call it unit form because when I look at this three-dimensionally, my I vector, and I'll try to find a place to write that. So my I vector is coming out in this direction here, 1 unit. So if I was to write that vector would be 1, 0, 0. And that's the I vector. So when I write 4I, that's what I'm actually looking at, excuse me. And then the next vector I'm going to write is the J vector. And the J vector goes 1 unit in the positive Y direction. And to write that vector, I should move my other one over. No, I'll just write it up here. I'll just put an arrow. That vector is going to be 0, 1, 0. And that's my J vector. And then my K vector is going in this positive Z direction, and that's up 1. So that vector, oops, let me draw a better line there. That vector is going to be 0, 0, 1. And that's my K vector. Okay, and that's why they call it a unit form, standard unit form, because the number 1 is a unit in general. Okay, so now we're going to look at the magnitude of V. So I'm just going to take that vector PQ and move it to the center. And I'm going to get all that other stuff out of the way. So this is kind of what it looks like. Well, this is what it looks like. So I'm going to take this and I'm going to move it downward and just put it here. Well, that looks pretty good. And that's going to be where it's at now. Now I'm just going to kind of move, and I'm actually just going to get rid of everything else from this because it's a little bit of noise. And I want you to kind of see what happens here. And we know this point out here is going to be that 4, negative 5, 3, which is this vector right here. So that's how far that point's going to go out, though. Because remember, now our initial point is at the origin, because that's what we did. Okay, so now what we're going to do is I'm just going to draw like a box for this. I'm going to start on the positive x, oops. And then I'm going in the direction of negative 5y, and I'm going to bring that up now. And then I'm going to go up 3, which would bring me right to there. Now the reason why I put these all in there is because we're going to talk about this magnitude now. And I want to talk about it geometrically and algebraically. So we have this vector here, and if we look at these values here, this side here is going to be 5 or negative 5, but I'm just going to call it 5 here, just so we can kind of get an idea of these numbers themselves. And then this side here, that's actually going to be 4. And then when I look at this side here is actually going to be 3. So that just kind of gives us an idea of what we're dealing with here, because when we're going to find magnitude, we need to find the length of this vector here. So the way we're going to do that is I'm just going to kind of draw figures here. I'm just going to draw figures here, not kind of. And that's going to help me to get a nice picture that I can actually graph. So now notice this here. I just drew a line through the center, a diagonal here on that parallelogram. So now I know that this side here is 3, and the actual triangle I'm looking at now is this one here. So this side 3 comes into play with it, but I don't know anything more about it than that. But I can use this 5 here, and then this 4. That means this here is also 4. So what I can do here is I can find this distance on this thing here. And the way I can do that is I can use the Pythagorean theorem for that, because when I look at this triangle, this here is a right triangle. This is 5, this is 4. And I could find out the hypotenuse from there, which is, and don't forget we're finding this h right here, this line. I'm calling it the hypotenuse, that's why I put an h there. So that's going to be the square root of 5 squared plus 4 squared. Now again, I know that's a negative there. That truly is a negative 5. But I'm just trying to find the magnitude here, so that's why I didn't put it in. Technically I would though, so just so you know. So this is going to be the square root of 25 plus 16. So that would be 41, the square root of 41. So that's what this is here. So I'm going to take that h out now. Square root of 41 there. Now I have everything I need to find that hypotenuse. And the hypotenuse I'm talking about is this one here. Because that's what I need. That is actually the magnitude of v if I can find that length. And that's what I'm going to do now. So I'm just going to take square root of 41 squared plus 3 squared. And this is going to equal, oops, I'm going to draw a little bit better, 41 plus 9. So that would be square root of 50. And 50 does have a perfect square in it. So it's 25, actually, 25 times 2. So this would be 5 square root of 2. So that's what that magnitude would be. 5 square root 2. Now, I'm going to show you a simpler way to do this. I just kind of wanted to show you the it's more complicated, I guess, in a way, because I got to draw pictures and they have to be kind of nice to understand where things are at. Now we're just going to do it algebraically. So that means it's just an extension of what we did two-dimensionally. So I square root, my first one is 4 squared plus negative 5 squared plus 3 squared. And then all I'm going to do is multiply this out. This is going to give me the square root of 16 plus 25 plus 9, which this equals the square root of 50. And again, I don't expect you to do it geometrically when you actually find these. What I'm doing here in the end is what I'm going to want you to do for your work for these types of problems. Definitely don't do it geometrically, but I just kind of want to show you how it works and kind of a neat idea there. So then this is going to end up being 5 square root 2, which is the same as I got going the more constructive approach. So there's our two answers for those. So that's essentially how we handle everything in 3 dimensions now. So in most cases, when we deal with these 3 dimensions, all the computations we had in 2-dimensional usually extend really nice into 3 dimensions, where I just add another component, and it doesn't really do anything more. I just add that component in there, like I did with this 3 squared here. Okay.